All right, guys, welcome to another episode of CUDA Education. There is in the ray tracing triangle example, I saw this. I saw this. When working through the script, I saw a lot of this storage image thing, right? And I'm like, what is this storage image thing? In the normal triangle generation that's non-ray tracing, and even just in the other scripts that are available, I didn't necessarily see this storage image variable, right? So there's this storage image variable, um, and it's all over this ray tracing example. So you have initialization of the variable, destructor. So you destroy the image view, the image, and whatever memory is associated with that situation. Um, Set up a storage image that the ray generation shader will be writing to, right? So yeah, there's this storage image thing, okay? Um, I guess this is where you're creating the image. Um, get image memory requirements, right? So we're doing memory requirements now, all of that stuff. Allocate memory, bind image memory. Okay. We got more image stuff. Create image view. All right. Um, storage image descriptor. Right. So there's all over the code. There's this storage image thing, right? Result image write. Okay. So initialize. Blah blah blah. So I guess now we're writing to the storage image, right? And this is under the function create descriptor sets. Okay. Um. So okay, right. So this piece of it, if the Windows resets, we need to recreate the storage image and its descriptor. Okay, so this piece now is similar to Swapchain resizing. So previous to ray tracing and just the regular Vulkan uh, sort of programming, if you resize the image, you have to the Swapchain images are resized. Okay, so here, because we have this storage image, if you resize the window, you have to resize the storage image uh, images too, right? Those images too, right? So right, so you're destroying stuff and then you're recreating stuff. Create storage image and then you kind of reprocess stuff again, right? Um, that's that part. So we kind of get that. Um, prepare ray tracing output as transfer source. Right. Okay. So copy ray tracing output to Swapchain image. Okay. So I'll get to this in a minute, but basically, right, doing as it says. Copy ray tracing output to Swapchain image. Okay. So ray tracing output to Swapchain image. All right. And then you do the actual copy. Right. Always remember when you have lowercase vk functions, you know it's something serious, right? But there's a lot of parameters that you need to prepare so that it would actually do what you're asking it to do. Okay. Um, okay. I think this now is you're basically blanking the storage image. I think that's what this is you're blanking transition ray tracing output image back to general layout. So general layout, I think, would be just like a blank canvas, right? That's what I think this is, but I mean, I'll have to put some more energy into it. um right, that's what this is, I believe. It's similar to in the swap chain images where um, you have a blank canvas. You write stuff. I mean, you have a blank swap chain image. You write stuff to the swap chain image. No. You have a blank swap chain image. You take the blank swap chain image out of the swap chain. You write to the image, the swap chain image. You place the image back into the swap chain. The image is then presented, and then you clear, after it's presented to the screen, you clear the canvas, you clear that image. Well, same so for swap chain images, same so for storage image. You have to, after you use it and you have kind of communicated to the swap chain what you want to do, I mean, what it is that you wrote to it, you gotta blank it. So that's, I think, the logic there. Right, create storage image, all of that stuff. Okay, all right. So let's get into it. So this swap chain image is basically it's an intermediary step that was introduced for ray tracing. I'm like, what's the storage image, the storage image thing, right? The storage image thing is an intermediary step used during the, for the ray tracing process, right? And I'm like, what is this for? So they added this intermediary step because there are a couple of reasons. One of them is that I guess ray tracing is a completely different animal. So the formats, the file formats, the resolutions, the pixels, I don't know, the definitions of the images may or may not be way different than what is available for swap chain images, right? So that was the first thing, is that you can create this storage image item, and you will have full control over the storage image. You'll have full control over what it is, and the format, and the color, the definitions, and everything. You kind of have more control over it than, say, you would if you were to just go directly you were to directly just work with a swap chain image. So you have more control. Number two, you're not beholden to whatever the presentation surface is. You're not beholden to the presentation service of the current context or the current application. So, if it is that you're presenting to a laptop screen, and the laptop screen, or a Windows machine, and the Windows machine only has a certain kind of presentation, that you're not restricted. Like you could do the ray tracing, and you could write the results of the ray tracing and the image to the storage image, instead of being restricted by whatever context the presentation is for what you're doing at that current moment, right? um uh Right. There's also considerations about read write access patterns, right, specific to ray tracing, which may differ from the properties and limitations of swap chain images. Okay, so that's another consideration why we have this intermediary step. Format, layout, and requirements. Um, right. So we kind of, okay. There's also a consideration for like synchronization. So um right. So remember, swap chain images are sort of, it's not just a standalone item. It's sort of an assembly line that keeps going. So the assembly line is always moving. So you know ray tracing is a lot more complex. It's a lot more things going on. So obviously when you take an image out of, or you know, a blank image out of the swap chain and you're rendering to it, the swap chain is expecting that you're going to put it back into the swap chain in a timely fashion, because remember, the swap chain, at the end of the swap chain, it's presenting to the screen. So there's sort of like an urgency where you know, you want to, you take it out, you write, and you put it back, and then you present to the screen. um, that kind of puts a lot of urgency on it. It also makes synchronization complex. But if you remove yourself from the swap chain assembly line completely, and you just have these storage images that you've taken your time to properly render, and you've written to them, and you could order them any which way that you want to, and you know, basically organize your situation. Then you could present to the you could submit these storage images, or copy them over to the swap chain in whatever order you want, right? So it sort of allows the developer to have more flexibility in terms of like what it is that they're pushing to the swap chain, and they're not necessarily under time pressure or synchronization pressure or presentation pressure, right? Because you could sort of do this independently, and you could even like write to several storage images and reorder the how the images are presented, right? So you sort of take yourself away from the swap chain assembly line, and you sort of do your own thing on your own time, and then you could present to the swap chain. Right. So you could put it back into the pipeline and put it back into the swap chain on your terms whenever you want. Image format restrictions. Okay, and then there's this idea of uh, you could use these swap chain images and put them into like multiple pipelines, right? So um, kind of above where I'm at now, but basically, you know, you have the flexibility of taking that swap chain and submitting it to various pipelines. um, and you know, you have that flexibility. I'm going to assume, based on that logic, that if you're writing directly to a swap chain, then your swap chain image, then you're basically beholden, you know, you're beholden to that one pipeline that the swap chain is in, right? So you have more flexibility. So that's basically what this storage image conversation is. I do have to spend more time in figuring out, you know, how it all works, but I at least wanted to start the conversation. So with that idea in mind, let's kind of go through again all the mentions for storage image. So here we're initializing something, and you know, of course, destructor. So the storage image again has image view, image, and memory. Now the swap chain images kind of had the same thing. I did a video where I basically did the whole cascade of all the 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 types that basically a swap chain images. So it's a really good video. It's actually one of my most popular videos, talking about the swap chain and like all the different types that go into creating an actual swap chain. So the image is the actual image, and then you have an image view like handler thing, and then you have some other stuff and some other stuff. I don't remember off the top of my head right now, but basically, you know, so you have it for the swap chain, so you have it for the storage image, right? So that's that. Um, create storage image. So then, you know, typical Vulkan fashion, you have to put in a bunch of stuff. This kind of reminds me of what a swap chain image is. Of course, you have the width and height of the storage image, right? We have, right, and then we have our VK create image here, lowercase VK. All right. Um, memory, we have to deal with memory, of course, and all of that stuff, right? So we got that. Okay. So let's just go through. Storage image. Right. So we got all of that. Okay. All right. So have to deal with descriptor sets too. Remember, anytime I see descriptor set, I just think of like a blank USB stick, but then you have to like describe what data is on the USB stick, right? Because you have to describe it to Vulkan and all that, right? So that's that. And then, okay, so result image write. Storage image descriptor. Okay, that's that. Right, and then of course, you know, remember I said with the swap chain, if you resize, if you change the window size in your presentation window, then basically you delete the swap chain and you recreate the swap chain. So same so for swap chain, same so for storage images. So you're deleting all the images, because all the images now are of the wrong size, because you yourself as a user has changed the input, I mean the width and height of the window, and then you recreate it. Okay, so that's that. Right. Okay. So prepare ray tracing output image as transfer source. So right. So this is now the operation of where you're moving the storage image from the from you're moving the data, or the information from the storage image into the swap chain image, right? So you could see you have storage image here, and then you have swap chain image here. Notice that you have source, SRC is source, and DST is destination. So when you see source and destination, you know, stuff like this, generally, you know, like something is being copied, you know, memory is being moved over, or data, what have you. So anytime you see SRC and DST, you have to outline what your source is, and you have to outline what your destination is. So here the source would be the storage image, and the destination would be the swap chain image, right? So that's that, right? Um, right, and then now you're resetting the swap chain image, because you've copied over the data from the storage image to the swap chain image. So then that storage image now, you know, it can be, you know, you could blank it and then reuse it. That's what I think this is doing right here. You're basically resetting the canvas, and then you're you know, so you could write, so the ray tracing output can write to this storage image again, new information, right? And yeah, and that's pretty much it. So this is the storage image conversation. Very curious about it. Like it's like when I first started investigating the script, I was like, you know, what's the storage image stuff like? I know swap chain, but like the storage image. So this is a good intro video to that idea. Obviously I have to do more research. I have to plow through the spec on this particular topic of storage image. I'm still though trying to work on some of the acceleration structure stuff. But let me talk about that in a different video. So anyway, guys, remember, if you want to be able to run all of these examples, especially the ray tracing stuff, you need a Vulkan-capable GPU, Windows machine, and you get tutorial number 1 and tutorial number 13. I know I got it wrong in previous videos. Tutorial number 1 and tutorial number 13. Tutorial number 1 installs the Vulkan SDK on your machine, and tutorial number 13 installs these examples here. You could only do the ray tracing ones if you have a ray tracing capable GPU. So there is a Vulkan capable GPU, but it isn't necessarily ray tracing. So you want a Vulkan capable GPU, and you know, if you could get a one that is ray tracing too, that'll be good. The NVIDIA RTX series, you know, has that capability, so you could do it with that. Get your friends together, work through this stuff, install the examples, um, you know, and work through it, and you could follow my guide for what I'm doing with this stuff, but then you guys could also work on all these different examples on your own, right? So you're not beholden to whatever videos I make. Like, you guys could go rogue and like do work through these examples yourself. Big shout out to Sascha Willems for creating these examples. um, you know, there's a lot of stuff. I think by the time you install these examples, you know, maybe, I don't know how far off into the future, but maybe there will be more examples than what's already here. But yeah, ray tracing is some really cool stuff. So don't just play video games. Learn how to actually um, do computer graphics and build your own world. And remember, the ability to put a pixel on a screen is applicable to any industry. It doesn't necessarily have to be gaming. It can be real estate. It can be business. It can be engineering. It can be, you know, whatever you want. And you know, you're not necessarily just forced to use whatever prepackaged software that is available. You could actually create your own custom stuff by yourself, and you know, make your organization that much more greater, and making the meetings and stuff more amazing, because you have the ability to simulate and render stuff. Okay, so that's a long-term picture, but you got to start now. You can't, you know, because time is expensive, and you got to start on the journey. That's just the first foot forward. So anyway, that's it, guys. Thank you for watching. I will see you next time. Bye.